So just to kind of give you an idea where we are, so this is the Lake 90 slope stabilization project. And so what's going on is that we have the Chagrin River right here, and it's starting to meander a little bit into the embankment itself. And we are attempting to provide a stabilization structure so that the stream can continue to meander, and the embankment and for Lake 90 here will kind of continue to stay more stable. And so what slope stabilization is, it is the protection of and stabilization of weak rock and or soil materials that are used to build our embankments. And so in many cases we have like weak soils that we're having to that are either have to be removed or stabilized. But in this case, we are really having an issue where we have material being taken away at the toe by the river here, and then we have the structure itself is going to be stabilizing the entire embankment to our left. What a drill shaft is, in essence, it is a concrete and steel reinforced circular member. If you've seen like a column on a bridge, it's very similar. So for this project, that we are using I believe it's a 30-inch drilled shaft. So what they're going to do, there will be a very large rig that will be coming in here. They're going to come in, they will drill a vertical hole into the ground. They'll kind of take all that dirt out of the ground and put it into a stockpile for it to be removed at some point during the construction process. Then they will drill it all the way down. They will pull any material that's loose in there. They will then probably place these W shapes right here. They will place one vertically into the ground, into that hole that they've set, and they will fill it with concrete. And so for this project, the way that it's constructed is called a tangent wall. Each of those drill shafts are going to be drilled, so there's one, and then the next one will be drilled almost immediately to it, so that they're connecting at one point, and then it'll be just an entire straight line of these drilled shafts. And so when everything is constructed and all the concrete is cured, it will behave as one solid wall. You'll start at that first one, and then they'll pour the concrete, or they'll put the shaft in and pour the concrete. Concrete has a time frame that it's going to require to get up to strength. And so the contractor, they can't drill that next one immediately next to it, because the concrete will still be wet. If there's any kind of soil weakness, it will flow into there. So what we're trying to do is we're trying to ensure that each of those columns is structurally sound, and that all the concrete is kind of forming that around there to encase the beams that we have here. So the typical construction operation is that they will do one, and then they will offset a couple. They will do that one, and then they will kind of follow that leapfrog process all the way down the line. And then usually that'll take a day or several days. I don't know how fast these guys work. But usually over several days, they'll kind of move down the line. Then they'll start back at the top. That first pile has had time to cure. It's gotten to its minimum strength. And then they'll start there again. And then they kind of keep that leapfrog process moving down, so that eventually there will be a whole wall, but it's going to look a little strange if you were to watch it in straight operation. It's a permanent method. Even if the stream continues to meander into the embankment, the drill shafts are going to be there permanently, and the stream can do whatever it wants. Everything from me to the right, the street, it's all the streams, and then the drill shafts will be there to make sure that the embankment and the road are going to stay where we put them. The reason that we're doing it in this way, there are a million ways to retain earth, but in this case, using a drill shaft wall, it's the footprint is very limited. So for the most part, it is the area where the drill shaft wall is, and then there's no disturbance in the front or the back. Because if you look here, there's been 5,000 cars that have passed here in the time that we've been here. So disrupting traffic and having a large excavation to the back end of the road was really not an option. And then additionally, again, with the stream being right here, we were attempting to keep all material out of the stream if at all possible. But in this case, again, the drill shafts are going to be outside of the river. We're not going to be anywhere near where the water is going to touch. So we were able to drill these things. Once the concrete is cured, we can put the road back, we can shift traffic back, and it'll be ready to go. and that's it. One good thing that with this method and the construction that we're doing is if the stream meanders further, extending this particular system is going to be a relatively straightforward process. There is, again, like I said, that we can basically create another plan, and we'll find the edge of the last shaft. We can start drilling there and kind of move that way. So, as Mother Nature decides to do whatever it wants to, we can relatively easily and straightforward, continue to protect the embankment and then let everything else kind of be wild on that side for as long as we need to. Rivers get to do whatever they want to in a lot of ways. They have a mind of their own in many cases. So for this location specifically, actually, if you kind of look to our left here, with the original construction of the highway, the river itself, it starts back in the back here, and it would actually move north around this to the shale slope here, and it would turn back this way, and then head back towards the lake as we continue east. But then what happened with our construction is we built this embankment here, and then we relocated the stream to its current configuration. And then so over time, what ended up happening is the stream is starting to meander back towards its original location as it is now. And so it is something that we have to deal with all across the state. There's a lot of ways that it can be handled. This one is a little unique because it's a scenic river right here, so there's a lot more like concerns about how it's going to look, trying to make sure that we don't disturb the water quality, and a lot of other things that were kind of handled and discussed as we kind of came to the final solution of the drill shafts for this project. As I said, this embankment was built and then we relocated a stream, and very typical of 70s and 80s. But now there are a lot more stronger waterway protections, and if we were going to have to do something like this again, where we would have a highway over a meander or over a river, we would like to build a bridge in this location, because the Army Corps and other permitting agencies are very concerned about like the placement of material into a stream, and moving the current or the flow of a stream is something that is much higher concern than it was in the past. And like I said, it would be a much different configuration and design if we had to do this again. This entire project was actually originated from a conduit inspection. So we have a median catch basin kind of over here in the middle of the 90 median that drains outward into the stream. And as part of the conduits that we have within our system, we're required to perform inspections on them to kind of keep an eye on them, identify their condition, and then allows us to kind of plan into the future as to how much life each of these things have within the ODOT system. And our inspector happened to keep an eye on this general area. He's here every couple of years, and he noticed that this stream was continuing to come further and further in. And so he flagged this as like, hey, this is something that is not part of the conduit itself, but like it's a larger issue. So we started taking a look at it. You come out here, you stick your head over the embankment, and all of a sudden you kind of start the process of making a larger plan to kind of handle something that they weren't expressly looking at, but they found, and they kind of moved it up the chain, trying to make sure that everything works. The embankments stay there, the conduits stay there, and everything in between. Maintenance people are the people that are out here day in and day out. I mean, they're walking along the embankments, they're checking guardrail, they're checking all sorts of things that I am not able to go out and look at. Men and women that are a part of our maintenance forces are there. They're the first people that see something, and for many years I would get at least one phone call a year going, hey Kyle, you need to come out and like look at something. And I'll come out, and all of a sudden stick my head over a guardrail, and you're like, yep, they've got another project generated. It's very critical and crucial that we kind of are able to communicate.